Okay, let's start from question 6. I said the reason why I want us to look at question 6 is because I see that there is an interesting question here. I see that at the D point here, we are asked to determine the point of maximum. We have to determine the magnitude of the maximum bending moment. So that's why I want to start from here, because others is just the same question. Calculate the reaction, calculate the bending moment at each section, draw the shear force and bending moment diagram, which we already understand the concept. Okay, let's quickly start this because of time. It's Friday, we only have 15 minutes. Okay, so the first question here says that we must calculate the reactions at the support B and E. The reactions at the support B and E. Yes, Claudius, we're going to look at that. If one point of the beam is in the wall, that is a cantilever. That is question 5. We're going to look at that after this one. So that one is a cantilever. I'm going to show you how to do calculations and how to draw shear force and bending moment. Let's just be fast, and because of time, those are the things I want to cover today. All right. So let's start with this one. Guys, don't mind me if I'm coughing. I'm having a bit of a flu here. Just trying to clear my throat, if you don't mind. Okay, let's look at this beam. Let's calculate the reaction without wasting time. That is the A part. If you look at this beam here, we have a UDL section here, which it covers the 4 meters. So this is going to be 24 what? 24 newtons. Because we have 6 kilonewton per meter there. So for 4 meters is 24. So we need to determine the reaction here, the reaction at the support, which is what? B and what? B and E. So that is question mark. B rather. Okay. So what we are going to do here is I'm going to be taking moment about support E. Summation of moment about E is equal to what? 0. So I'm just going to be writing. So I have this to be a clockwise moment. This is counterclockwise, this is counterclockwise, and this is also counterclockwise as well. And then we also have another one here, which is also what? Counterclockwise. So we have one clockwise. So that's going to be RB multiplied by, is RB multiplied by 9. That's 9. Then we're going to have equals to 5. 5 multiplied by 10. The distance between that force and E is 10. Then plus. So I'm adding all the counterclockwise moment now. So this is going to be plus 6 multiplied by what? It's going to be plus 6 multiplied by 6. Then plus. I have the force there at the center there, which is 24. So this is going to be 24 multiplied by 4. It's acting at the center. The distance there is 4. Half of that distance is 2. 2 plus 2 is going to give you 4. Then I have another force there, which is 4. So which is plus 4 times 2. So this is going to be 9RB equals to, so I have 50 here plus 36. 50 plus 36 plus, I have 24. 24 times 4 is going to give me 96 there, and I have plus 8. So I want someone to give me the value of the reaction at B. So it's going to be 50 plus 36 plus 96 plus 8, all divided by what? 9. So can someone give me the value of the reaction at B there? What did you guys got? I'm expecting that you guys would have solved this question. Okay, 21.11. 21.11. You're going to use the same unit, which is kilonewton. And let's get the other reaction very fast. summation of upward forces equals to summation of what? Downward forces. So our upward force is RB, which is 21.11 plus what? Plus RE is going to be equals to, we have the force 5 plus what? 5 plus 6 plus plus 24 plus what? Plus 4. So can someone give me the value of the reaction at E? So you just add all these values together and then you subtract from 21.11. 17.89. That's correct. That is 17.89. So if you add all the upward forces and the downward force together, it will balance. Okay, so that is that. Bending moment at each section, that is A, B, C, D, and E. Um, Let me do that here. For the bending moment, that is the B part. Bending moment at each section, that is A, B, C, D, and E. So we know that the moment, the moment at A, because it's at the extreme, is equals to zero, is 0 kilonewton meter, and the moment at E is equals to 0 kilonewton meter, because we don't have any distance there. So we are going to look for the moment at B, moment at C, and moment at what? At D. So the moment at B, um, I said that we are going to, I said that we are going to use sign convention, right? And with the sign convention, using sign convention, if it is pointing down, you use negative sign. If the arrow is pointing up, use what? Positive sign. So for the moment at B, so I'm going to be walking from the left to the right to the section. So it's going to be what? Minus what? It's going to be minus 5 multiplied by 1. So this one is going to give us minus 5 kilonewton meters. Moment at C, I'm still going to be walking from the left to the right. It's still convenient for me. So between my left and my right, between my left and that section there, there's a reaction there, reaction at B. Let's just write it 21.11, 21.11 acting there, kilonewton, and the reaction at E is 17.89 kilonewton. Okay. Okay, so for the moment at C, I have 5 kilonewton and that reaction at B there. So I'm going to have minus 5 multiplied by the distance between A and C is 4. So minus 5 multiplied by what? Multiplied by 4, then plus. Then I have my reaction, which is facing up. 21.11 is going to carry positive sign. Multiplied by what? The distance there is 3. Someone should give me this value. The bending moment at D, I'm going to walk from the right to that section because it's going to be much more easier. So for bending moment at D is just going to be positive because the arrow there at the reaction at E is facing up. 17.89, 43.33 kilonewton meters. So the next one there, 17.89 times 2, this is what? 35.78 kilonewton meters. Is this what we got to, guys? So we've quickly calculated that one. The next one, you have to draw the shear force and bending moment diagram. I told you guys, I said that you have to draw them on the same what? On the same line. So let's draw the shear force and the bending moment diagram of that. So this is what I'm going to do here. I'm just gonna draw a line there. I said that when you are drawing this diagram, you can as well draw according to scale as well. So I said the first thing that I'm going to do here is to label. So I have my point A, point B, point C, point what? Point D, and point E. So you need to highlight the sections out. So I'm going to start now. So let me write out, this is 21.11, and then this one is 17.89. So in order for you to draw your shear force, you need all the values of the forces to be indicated on the diagram. So how am I going to start? So I'm going to start by indicating the dot. So the first one here at the tip here is what? 5 kilonewton. So 5 kilonewton is pointing down. So I'm just going to indicate that here. So this is going to be -5. And then between A and B, there is a straight line. So you're going to have a straight line there. So we have -5 plus what? You're going to have -5 plus 21.11 because 21.11 is facing up. So that will give us what? 16.11. So at B there, this is going to be what? 16.11. So between B and C is an horizontal line, but at C here, the force is going to be affected at this point here. We have 6 kilonewton pointing down. Don't forget the sign convention. This is positive and this is negative. So it's going to be -6 plus what? 16.1 minus 6 is going to give us 10 point what? 10.1. So we're going to have 10.1 at this point here. So 10 point what? 10.11. Okay, so between C and D, we have a force that is acting at the center here, which is what? 24 kilonewton. So it's going to be, because it's pointing down, it's going to be minus. So it's going to be 24 minus the last force that we got that is acting there is 10.11. So we are going to get 13 point what? 13.89. So that will be indicated here. So at this point where it touches D here is going to be what? 13.89. But there is a force that is also acting down. So it's going to be minus 13.89 minus 4. So this is going to give us minus 17. It's going to give us minus 17 point what? 0.89. So between D and E, there is no force. It's going to be an horizontal line. And that we have another arrow that is pointing up. I told you guys when I was teaching you last week, I said this thing has to close to zero. If it doesn't close to zero, then there is something wrong somewhere. So here we're going to have minus 17.89 plus 17.89 because it's pointing up is going to give you what? Zero. So it started at this point to -5 to 16.11 to 10.11 to 13.89 to -17.89 to zero here. So it starts from zero and then it must end at what? At zero. So what I'm going to do here is to draw my lines. So I'm going to draw a straight line here coming down. I'm just sketching here. My hand is not straight. So I'm going to draw another line again. Between A and B, there is no force. I'm just going to draw another line again. B here. Then I'm going to draw another line again, which is going to go up there. I'm going to draw another line again. Between B and C, there is no force, so the force is going to act horizontally there until it reaches C there. And then from that point there, I'm now going to draw another line down here. We got another point there, which is 10 point what? 10.11. I'm going to draw another line from 10.11 to what? To 13 here. 13.89. Then from there, I'm going to draw another line that is going down. I'm trying to join all the dots now. Straight line down. And then I'm going to draw another straight line here to this point. Then I'm now going to close my line at E there. So that's another straight line up. Okay, so this is the shear force diagram. This is the shear force diagram. I believe you all got that. Okay, let's draw the bending moment diagram. The bending moment diagram is the easiest. So with the bending moment diagram, we are just going to, let's draw the bending moment diagram very fast because of time. I'm having 24 here, 24 kilonewton here, 21.11 here. I'm having 17.89 here. Okay, so I told you that when you are doing your own diagram, your bending moment diagram must just directly beneath the shear force diagram. You must draw everything on a what? On a fresh page. Don't separate the diagrams. So the reason why I'm separating the diagram is because there is no space here. So when you are doing your diagram, it must be on the same page. Make sure you use a full fresh page. You first draw the beam, and then you draw the shear force beneath, and then you draw the bending moment diagram just directly beneath the shear force diagram. Right? Let's draw the so I'm just going to do this just the same thing that I did. I'm just going to draw a line that is the same length as that of the beam. So I have my straight line. So what I'm going to do here is what I need those values. So what I'm going to do here is I'm just going to crop out this. I need these values in order for me to draw my bending moment diagram. Okay, let me just put them here. Okay, let me just put them like this. Okay, let's start. Bending moment diagram is the easiest. This one is 0 and this one is 0. So we can label them. That is this is A, this is B, this is C, is very important. This is D and this is E. So bending moment at A is 0. That is 0 right there. This is 0 and this one is also what? 0. Bending moment at B, we got -5, isn't it? So we are going to just come there and just put -5 there. Bending moment at C, we got 43 points. So we can just do this. That is 43 point what? 33. Bending moment at D is what? 85. You can just do this here, 35. Just say this is 35.78, and then this one is 0. Concave up, concave down. No, this one is going to be a straight line. So let me use my hand to draw the straight line. Let me just draw a straight line. And then what's going to happen between C and D? I wanted to see something here. It will first go up a bit, and then it will come. This is going to be a curve. It's going to be a what? This is going to be a curve. Let me see if I can try again and draw it accurately. Okay, I think that is okay. And then between D and E is there is no UDL there, so you just draw a straight line. Okay, this is where I'm interested in, guys. The last question here. Calculate the maximum bending moment. Now, there is something I want to tell you here. This is also in strength of materials and structures. Now, the point of maximum bending moment is a point where the shear force touches origin. Remember, this is the origin, O00. There's the origin, this is the positive side, and this is the negative side. The same thing with this as well. This is the origin, 0, 0. We have the positive side of the graph, and then we have the negative side of the graph. Oh, sorry, I did something wrong here. This is supposed to come down first. Sorry, I didn't see that. Then this will now come up like this. Question. Yes. Is it Mabaso? -5 plus. No, 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 no. We don't do that on the bending moment diagram. You just put the point that what you got to just indicate it there. You don't do all those calculations on bending moment diagram. You only do the calculations on the shear force diagram, which is this one. So with the bending moment diagram, we have calculated it here. Remember, or you join late. We have calculated the bending moment at each section here, section A, B, C, D, and E. So we just need these values to plot the bending moment diagram. Do you understand now? So we don't do those calculations. We already done that here using sign convention, and then you just have to just put in the values there. So this one is the easiest. Okay, I was explaining something, guys, that when you are dealing with beams and structures, the point of maximum bending is the point. Let me indicate it with a dotted line. The point where the shear force diagram touches, or the point where it crosses. Now, if you trace this point down here, the reason why you have to draw your bending moment diagram just beneath your shear force diagram is because of questions like this. So if I have drawn my bending moment diagram just beneath, so you just trace that point to, let me do this. Just trace that point to, you just, maybe it's here. And you see, so the point of maximum bending is not 43.3, is actually at this point. So it can see that it's a bit of a curve that goes up. It's because of my hand. It just is because it's hand sketch, and that the point of maximum, let's just say, is just a bit here. You have to make sure that this straight line is drawn onto the bending moment diagram. So the point of maximum on the position, uh, let me do this. So it's going to be from A here. You draw a line. So we need to get that distance first in order for us to be able to get the magnitude. Okay, so that distance there is from the extreme left. So let's say that distance there is distance y. Let's say it's y meters. We don't know. Now we don't know that section. Actually, we don't know that section. So we can just assume that, let's say this is what? This is xx. Okay, so how do we get that distance? So that is, we need to get the position first, and then after we've gotten the position, then we are now going to take moment about that particular section. We're going to take moment about the section, and then we'll be able to determine the point of the magnitude of the maximum bending moment. Let me just do this. Okay, so let's just assume that is, so we, it simply means that we are going to take moment about this particular section. So whatever value that our bending moment gives us is going to be the value of the maximum bending moment. I believe you are following me. No, don't use different colors. Just use pencil. The reason why I'm using different colors is because I want you guys to see a lot of details there. Use pencil. Only pencil is allowed, please. When you are drawing the final exam, please use only pencil. The only way that you can use to demarcate or to differentiate them is, like the axis, you can draw it with a faint, maybe 0.3, and then you can draw your actual graph with maybe 0.7 or 0.5. No, 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 don't do it on the same axis. Like what I said, you have to draw your bending moment diagram just beneath the shear force diagram, and don't use different colors. It is not allowed. Don't use different colors. You can, there are some things that you have to draw that you probably indicate by using a 0.7 millimeter, believe for some of you that are day drawing. 0.7 millimeter is more thicker than 0.3. So you can use 0.3 for your construction lines like the origin, and then with the actual diagram, which is the shear force and the bending moment, you can use 0.7 millimeters lead. Then with the origin, you can use 0.3 millimeters lead pencil. Okay, do you understand? So that one is faint, and then the other one is more thicker. Okay, let's finish this because of time. I always complain that there is not enough time for me for engineering science. Maybe we should make it 2 hours or something. Okay, so now the first thing we have to do here, we have to calculate that position there. And we know that the shear force, follow me now, the shear force is equals to 0 at what? At x. Because the shear force, you can see, is 0 here. And you see the point where the line crosses the origin. So it's 0 at x. So what we are going to do here is that you are going to sum all the forces from this point, all the forces that are between this region A and what? A and X. So you're now going to write this as, the first one is 5 kilonewton because it's facing down is -5, plus there is another force facing up there which is 21 point what? 11. There is another force facing down there which is going to be minus what? -6. And then now I want you to look at this place. Now there is a UDL here, uniformly distributed what? Load. Oh, sorry. Between this point and this point, between C and X, the point where we are taking into consideration. Okay, so that distance there is going to be what? Is going to be is going to be y. Remember, the distance from here to here is 4. So that distance there is going to be what? Y minus 4. And then the UDL there is what? Is 6. So you're going to write it as minus 6, then minus the center load at that particular point there is you are going to multiply that UDL value by the what? By the distance, which is y minus 4. So everything equals to 0. I believe you understand what I did there. So you are now going to have minus 5 plus what? Plus 21.11 minus 6 minus what? Let's say this is minus 6y plus what? 24 equals 0. Can someone give me the value of y here? Can someone give me the value of y? It's going to be minus 5 plus 21.11 minus 6 plus 24. And then whatever you get, to take it to the other side. Just give me the value of y because of time, guys. Thank you. 5.685. Okay, so that distance there is 5.685. So I can indicate that here 5.685 meters. So what I'm going to do now is I'm going to take moment about that section, that X. So what I'm going to do is I'm just going to take this because I need to do another calculation now. I'm just going to take I only need this. Okay. So I'm going to take moment about X, summation of moment about that section. We said the XX is the point is equals to what? 0. Is equals to 0. Okay? Let me just write it like this. Bending moment about X is equals to what? Let's start. I'm going to need, sorry, I'm going to need the beam. Let me just put this down here and I'm just gonna do this. Okay. Let's take moment about X. If we take moment about that section, then we'll get the value of the maximum bending moment. So moment about X is equals to what? It's going to be equals to, we're going to use sign convention. So it's going to be minus 5, right? Minus 5 multiplied by what? The distance of Y there is what? 5 point what? 5.685. Okay. I'm working from this point to the point where we have our X here. Point of maximum bending moment. Plus, I have another force here, which is what? 21 point what? 21.11. So I'm going to have, because it's facing up, is 21.11 multiplied by, now what is the distance? 21.11. I want you to look at something here. Minus what? Minus, remember the distance from this point to this point is what? 5.685. So 5.685 minus 1, because there is 1 here, is going to give us 4 point what? 4.685. Then I have another force facing down there, which is 6. It's going to be minus 6. Now I have the distance between A and C is what? Is 4. So 4 minus Y. That is 4 minus 5.685 is going to give us what? 1 point what? 685. Then there is another force in between here, because there is another UDL here, remember. So remember, this is still 6 what? Kilonewton per meter. So that distance there is what? Is 1.685, because you see C multiplied. So it's going to be minus 6, right? Uh, let's say the force is 6 multiplied by 1.685 multiplied by 1.685 over what? Over 2, because it's acting at the center. So can someone give me the value of the maximum bending moment? You have any questions that you want to ask here, guys? I just took moment about that section, which is X. 51 point what? 852. Thank you. 51.852 kilonewton meters. This is the what? The maximum bending moment. The value of the maximum bending moment is 51.852 kilonewton meters. Who got this? The reason why I multiplied this is because there is a force between C and X. There is a concentrated load that is acting at that point, because we have a UDL there. So you have to multiply the force by that distance there. The distance here is what? Is 5.685 minus what? Minus 4. So the distance there is 1.685 meters. So that's the reason why I multiplied them together to get the force. Then of course you have to, because you are taking moment about X, because it's acting at the center, you have to divide the distance by 2. That's the reason why we have 1 here and 1 here.